Aegis team. Then we will focus more onto the main subject of this workshop, which is what data can be tracked with the usage ping. Then we'll also cover in a brief detail how usage ping process works and reports data. And then we go into more technical aspects, covering how to add, change, and remove metric. We'll conclude everything with the live demo session and the Q&A. And I hand over to the Alina.
Thank you, Mikolai, for presentation. Hello, everyone. We're going to start by speaking on a high level about the tracking tools we have available and what we can achieve with the product intelligence framework. So we have here usage ping. Usage ping is a collection of aggregated data. Usage ping is available for both self-managed and GitLab.com. Reported information in usage ping doesn't have additional data. This means that it doesn't allow for further slicing up in analysis. Secondly, we have Snowplow. Snowplow is again available for both GitLab.com and self-managed, with the mention that each self-managed instance could set up their own Snowplow collector. And for GitLab.com, we are the one managing the Snowplow collector, so we have access to the data that we collect there. Data in Snowplow is not aggregated. It could have additional information and details. For example, we could have namespace ID there. More about the collection on Snowplow, we were going to have a follow-up workshop session for that, where we are going to share more details on this tracking. Now more about usage ping. In this session, we are going to focus mainly on usage ping and what data we can collect here. So for usage ping, it's important to know that the data should be stored previously. Only that only data that is previously stored, either in database or Redis, for example, can be then surfaced in usage ping. So we have here a couple of examples. So for example, we can collect data from database. This means this consists mainly in counting rows in different tables. As an example, we have total number of issues created. Another example could be total number of users which created issues. Some other information that we can surface is different instance settings, license data. I'd like to share a bit more in details how usage ping is working. So basically, usage ping is a cron job which is set up to run on a weekly basis. When the cron job is triggered, we cascade down in computing more than 4,000 metrics. So all the results from this computing is merged in a JSON payload, which is later saved in a raw usage data table. Also, this JSON payload gets posted into the version application, which is a separate application where we collect data from both self-managed and GitLab.com. From there, we import the data in data warehouse. Later, usage ping data is available for visualization in Sisense. Data is available up to 38 days upon releasing. And this is a slow cycle because we have the monthly release base at GitLab, and also because of the weekly generation of usage ping. So in the right side, you can see an example of usage ping. There are a couple of examples of data that we can have there. In the top, there is some instance-specific information like installation type, license-related data, the version that the instance has. Also, we can see a couple of counters there, some events count, some issues, and some other counters from database rows.
And now, when we get the highlight overview, how the usage ping works and what data can be tracked, let's dive into the more implementation details. starting with the process how to add the metric to the usage ping. First of all, I would like to highlight, as Alina mentioned, that we have over 1,400 metrics already tracked, and it may be very possible that the metric that you want to use is already tracked. So we advise for you to, before instrumenting new metric, to check with our metrics dictionary to see if there is one that could cover your business case. If no, then you should follow the next steps. First of all, you have to consider if the data that you want to track is already recorded, because as Alina mentioned, only data that is somehow stored can be later surfaced via usage ping, and data could be stored either in database or in Redis or in the license or settings. If the data is not stored, then it has to be first recorded, either in Redis or in database. And finally, it can be collected and instrumented within the usage ping. Once the instrumentation is completed, you should proceed and add the documentation with the metric YAMLs file. And finally, you should include your new added metric into the metrics dictionary for the other teams to collaborate and use by regenerating the metric dictionary with supportive script. So when adding the metric, there's two main places where the metrics could be included in the usage ping payload, which are lib gitlab usage data.rb or eelib gitlab usage data.rb files, corresponding for the metrics available in both community edition and in enterprise edition only. Then you should consider one of the 5 top level keys that are available. And those keys are counts weekly, counts monthly, or settings. How to choose correct top level key? You first has to answer the question if the metric that you want to instrument is time dependent or not. If it's not time dependent, then you should place it under settings top level key. And if it is time dependent, then you should consider which time constraint is applied. Whether this metric is calculated based on last 28 days of data, last 7 days of data, or includes all available historical data. Then counts weekly, or counts monthly correspondingly should be selected. And back to Alina for the hardening methods.
So now that we've seen where to put our metric and where to locate them in usage ping, we can proceed further and see how to choose the correct methods for adding metrics. Over the past year, we worked in our team to add a number of specific methods to build the usage ping metrics. One set of metrics would be count and distinct count. These methods are database specific methods, and here we would count rows in different tables. These counters are, for example, total number of issues, where you get as parameter issues, or total number of users creating issues, or distinct count for getting the user number. Other counters we have are the Redis counters. So are used for in-memory counts. For this, it's important to remember that the data needs to be before tracked. So first we need to track the data and add it to Redis, store it to Redis, and then later when we want to add it to usage ping, it should already be available for us to use. We also have alternative counters. This would be for various data like license data or settings. Another number of methods are documented. I would like to mention that is it important to use one of the described methods, because these methods are implemented in such a way that they are failing safe. What this means is that having, for example, a failure in one of the metrics will not fail the entire usage ping. This is important for us to know that we're going to fall back in a specific fixed value. Having one metric will not break the entire usage ping, and we can collect the rest of the data. Next, we'll have an example of some of these methods that I described, count and distinct count. Here, in this case, we have packages, counting packages for last 20 days time period, or counting alerts for counting number of projects in alerts table, project alerts table. Part of the implementation, we recently introduced the metrics definitions. These metrics definitions are YAML files. They have a number of required attributes like keypad, which is the exact location in usage bin, descriptions, name. For more about naming conventions a bit later. We have the product attributes, which this will be also part of the information which tell us who owns the metric, distributions and tiers, status and value type. For this, we have also a tool which will help developers to generate the files in the correct location and with a set of data which is pre-filled. We have these files as a documentation will serve as a single sort of truths for our documentation for all the metrics in usage bin. It's important to know that each metric in usage bin will have a corresponding YAML file. We see in the right side an example of YAML file for one of the metrics we have in usage bin with the field attributes. We prefer to be as verbose as possible and have detailed information in these files so we can understand and get a well understanding when looking at this file about what the metrics is about, what information do we get, who is owning the metric, from when is available, or the source of the data. From these files, we're generating the metrics dictionary. So a while ago, we deprecated the event dictionary. The event dictionary spreadsheet was starting to be hard to maintain and work with. And we consider that it's better to have the documentation in our code base. Now that everything is moved in our code base, from these YAML files, we can generate a dictionary. The dictionary is a simple markdown file, which is then generated using a rake task based on the definitions that we have in YAML files.
And now let's look more into the metric naming. First of all, I want to highlight why it's very important to select well-formed and verbose name. With over 1,400 metrics included, we have already quite solid foundation and solid library for other teams to reuse for many different use cases. But in order to help other team members use and discover the metric that they may consider interesting, we should have very meaningful and explicit name that help us find interesting metric easier and avoid collecting redundant data. And how to select the proper name? First, we introduced the naming suggestions that are included into the metrics YAML generator. And this name suggestion would prefill the name attribute based on provided keypath argument. And that is why it's very important to first instrument the code and then only generate the metrics YAML, because that's the only way we could provide corresponding name suggestion. The name suggestion could come in the three forms based on the selected instrumentation hardening methods. For the metrics collected from the database, the name suggestion would consist of two different types of information. First is the information which is provided as a free text, and this is sourced from the well-formed algorithm, and it shouldn't be changed. And then there is name suggestion, which is provided within the HTML tags. This is the place where our algorithms are unable to provide well-formed name based on the existing information, and we ask for users for help to provide the best description. Users are expected to either remove the HTML enclosed name suggestion parts or replace them with the adjectives of their choosing. For the metrics collected from the Redis, all the name suggestion is the enclosed in the HTML tags, which means that the user is free to select them as they see fit. However, we strongly recommend to follow the format of subject, verb, and object when choosing the metric name. For example, user creating epics or merge request viewed in single file mode. And finally, there is the name suggestion, which fits all the rest and mostly alternative counters. which have variety of forms, and because of that, we are unable to provide well-formed and structured name suggestion. And we ask here for the best judgment of the users to provide the most descriptive name. And now, when we went through all the details onto how to instrument and document the usage ping, let's look more into the constraints and limitations that are applied to each and every metric. For the database counters, it's important to remember that we can only count the objects that are already existing in the database. So for example, capturing deletes or updates may not be possible or would be very challenging. Also, all the database counters should be reviewed not only by the product intelligence team, but also by the database team. And finally, all the queries that are run into the production database are constrained by the 50 seconds timeout limit. And in case of the usage ping, metrics that expand over the 15 seconds execution time would return -1 fallback value. For the Redis HL tracking, all the track should be added first behind the feature flag, and only after assuring that the performance of Redis clusters are maintained, they can be released. As well as it's important to remember that the data is only tracked in a weekly and monthly cadence for the Redis HL tracking, and there is no all-time historical tracking. And then back to Alina for the changing metrics.
Yeah, so what about changing metrics? Can we change the metrics? Is this even possible? So not really. It's quite a challenging job to change the metrics, and there are two aspects of this. One would be the keypad, so the location of the metric in the usage ping, and the second part would be the actual value of the metric. So considering the keypad, once a metric is released and we have instances that are updating and have the metrics there available, we are not in the control anymore. We're not in control of changing the code that is already released in GitLab installations. This would make a challenge to actually update the keypad of the metric. What if we change it? We might be in conflict. So if we have a key metric which is issues, and we want to define issues final, then later when the data arrives on us, we will have to map it in some way, which can be a challenging job. Another part with keypad is that we would not recommend to reuse old keypads. So once a keypad is removed, we cannot ensure that actually all instances have updated in latest versions. So we might encounter old instances using old key, and we might be mixing up with different types of value arriving from different instances. Secondly, the value of a metric. So once we decide that issues is count of issues, and then later if we want to change the logic there, how we would decide what we're counting. So we're gonna mix different values under the same keypad. So this would be the reasons why it would not be possible to change metrics in time. What we can do is actually deprecate the metrics and add new ones. So if we decided that we want to change the logic that we want to calculate a specific metric, we could deprecate the old one and add new one in replace. How to deprecate metrics? We should follow a set of steps to verify that the metric is not used in any aggregated metrics or any sites and dashboards, or in important places like conversational index. Once we've decided that we can deprecate the metric, we can replace the calculation of the metric with a fixed value in order to not add extra computing on usage ping. And later update the definition in YAML file with status deprecated. About removing metrics. So we can remove metrics, but we have to make sure that they are not used. For this, we will have to work together with data team to make sure that the metrics are not used in any dashboard and they are not going to break any dashboard in Sisense. Also, another part would be that usage ping arrives to version app and there is some processing there. We have to make sure there is not going to be any breaking processing in version app side. After that, we can clean the code related to the metrics, any remaining YAML files for feature flags or known events or any tracking specific to the metric. We're not going to remove the definition because we want to keep it the information for historical reason. What we want to do there is update the status of that specific metric with a remove status. So I think that would be it. It would be the end. I'd like to hand it over to Nikolai for showing us a demo on how to add the metric to usage ping.
Thank you, Alina. So yeah, let's head up to the demo and try to add the new metric to the usage ping. So first, let's see what is our goal. Let's consider the scenario when we are asked to provide the information how many users create issue each month. Before starting the instrumentation and documentation process, there's a number of information that we need to collect in order to make the process smoother. First of all, we need to check if the information that we want to track is already recorded in the database or Redis. How to check it? The most convenient way is to take a look at the structure.sql file, which contains all the information about the tables and the columns available in the production database. So let's head on and check if there's anything that we can use for our example. So we are looking for the table that tells us anything about the issues. And we can see that there was actually table issues. So it's good. Let's see if there's any column that will tell us anything about the user. And we can see that there's author ID there, so we are good. The information that we want to track is already present in the database. So we can write that there is table issues and column author ID. Then we will need to decide where the instrumentation would be placed and under which top level key. So first, there is no mention that this metric should be placed only in the Enterprise Edition, and the action of creating the issues happens in both Community and Enterprise Edition. So we know that we should place this metric in the lib GitLab usage data.rb file, which would then provide the instrumentation for both of editions. Then what would be the most appropriate top level key? We should answer the question about time dependence. So we see that we are interested in the issues that are created each month. That means that this data is time dependent and it would be collected based on the last 20 days of data. That means it should be placed in the counts monthly. Top level key. Finally, we should think what kind of hardening method would be the most appropriate. Since we know that we are interested in the users and not in the number of issues that were created, we know that we want to have the unique number of the values stored in the author ID in case of some author creating multiple issues during 1 month. So we know that we should use distinct count hardening method. With all this information that we already collected and decided on, we can then head on and start instrumentation. We should go to the usage data.rb file and add instrumentation at the selected key path. So let's do that. We decided that the most appropriate key would be counts monthly. And as you can see, there is one in the system usage data method. And there is number of already existing metrics there. We should go on and add another key and select well descriptive name. So let's use count distinct author ID from issues, because that's what we're actually going to count. Then let's use the selected hardening method, which is distinct count. Then we know that we are interested in the issue. So let's use the issue model and apply the monthly time constraint. And finally, we know that we are interested in the author ID column. And so that should cover for the instrumentation part. So let's see what we have to do next. Next comes the documentation process. First, we should generate the metrics YAML file with the usage of pre-existing customized generator. So let's copy the corresponding terminal command. It takes the key path as the argument, and we know that key path is already counts monthly and count distinct author ID from issues. And we also should appoint a correct directory, which is based on the top level key. For counts monthly, that would be 28 days. And we should execute the generator. And there is the YAML file. There was a YAML file created. So let's go in there and fill up all the missing details. So the key path and the name was prepared and pre-filled for us. Then we could add some description. For example, number of users who created issues each month. Then we should fill up the product information to appoint which team is taking care of the metric. Then we can see that another details were already prepared for us, like the value type, which is number, the status, which is implemented, milestone. For the introduced by URL, we should place here the URL to the merge request that added the metric. Time frame was pre-filled as well. For the data source, we know that we use the database, so let's add it here. We also know that it would be present both in CE and EE distribution. And finally, we already know that it should be tracked for every tier. So this concludes the process of creating and updating metrics YAML file. Let's see what we should do next. Final documentation step is to run the rake task to update metrics dictionary, so our new metric would be easy to discover for the other teams and reuse. So let's do that. And let's check if it was actually collected. And we can see that it was. The markdown file with the dictionary was actually updated. And we can see that there was added corresponding entry for our new metric there, which includes the name and the basic information, as well as the link to the metrics YAML file for the additional details. So we know that we are ready to wrap everything in the commit and push to the merge requests with the metric instrumentation. So what would be the final step? Before asking for the review and proceeding, we should also check if instrumented metric fulfills the performance constraints that are applied to the database metrics. How to do that? One way would be to go to the race console and collect the metrics from there, metrics query from there, and then check it in the database lab channel on the Slack. How to collect the queries? we can execute the same hardening method on the GitLab usage data class with the same active record relation as well as the appointed column. So let's do that. And there was 3 queries executed to collect this metric. First 2 selects the min-max boundaries for the last month, and the final collects the actual count. So let's select one of them, for example, the last one, and check if it fulfills the time constraints. So we are in the database lab channel, and we should execute explain command with supplied query. However, we should be very careful and check if the supplied batch boundaries are corresponding with the production use case. In this case, we can see that the batch limitations are quite small, and it's better to use a bigger one because the small boundaries were resulting of small number of records in my local environment. And in case of production, the default value is 10,000 records for each batch metric. So let's increase the upper boundary to 10,000 to get more real life feedback. And we can see that this metric was executed, the square would be executed in a 3.3 seconds, which means that we will fulfill 15 seconds time constraint. So we are fine. We could ask for the review and hopefully merge our metrics soon and get some feedback from the number of reporting instances. And that would conclude our live demo. And let's head on to the Q&A session now.
All right, thank you so much, Nikolai and Alina, for that great presentation. So we do have a Q&A doc that is linked in the comments. I see that.
Yeah, great. And great job on it, Alina and Nikolai and team. So the question is, can you elaborate on the differences for usage ping for self-hosted compared with .com customers?
So usage ping is available for both self-managed and GitLab.com. The difference would be that we are in our control of our infrastructure and where the usage ping works and runs, but we're not in control of the self-managed instances infrastructure. Usage ping is having the same logic for both, and the data reaches version app. We collect all the data in version app, and in the end, it reaches up in Snowflake data warehouse. One other thing that comes to my mind here is that for GitLab.com, we have releases every day. So one could check the metric already in when it's released. But for self-managed, we will have to wait for the monthly cycle to have any results. This is also something that maybe worth mentioning, that we would recommend to have the metric implemented as early as possible in a release. So you have the chance to verify before releasing to self-managed.
That's great. So follow-up question, the data on usage ping, and maybe we can cover this in the next session, tends to be a bit delayed because it goes through many steps before it's available in our analytics system, Sisense. So I know that's being worked on, but do you, and this is a question for the whole team, although I'd love to hear from anybody who has thought on it, on how that's going to change over time, because I know we're working on improving that, but just curious. Like, I think right now it lags by 2 weeks. It's currently lagged by approximately 2 weeks. So what are the plans? What are the plans to improve on that so the data is kept up to date more often?
So I can probably answer this one. Let me just find the handbook link inside our product intelligence guide so that I can reference exact times and all of the different steps. So I'm just linking over to the different steps involved inside of our agenda doc. So if you take a look at the link that I just pasted, what you'll see is that there are a few different steps involved when it comes to usage ping. So the first is the self-managed release. So we're bound by the 30-day release cycle for self-managed. That's the first thing. So it could take up to 30 days to be able to get your changes into a self-managed release. And then after that, we've allocated about 1 week to wait for customers to upgrade to the new release. So this is really just an estimated time, but as soon as we release a self-managed release, it takes a little bit of time for a user to be able to upgrade and for a usage ping to be generated, which is generated every 7 days. So we've allocated about 7 days there. Once that usage ping is generated, then the data is sent from that self-managed instance over to the versions application. And that versions application is imported into the data warehouse on a daily basis. So there's another 1 day there. So in total, a conservative estimate for the cycle time is 38 days. Now, in practice, what we've seen is if you're able to get your changes in by the 18th, which is usually our cutoff date for self-managed, we actually will have basically a code cutoff on the 18th. We'll have the self-managed release done by the 22nd, and then you add just a single day there. So on the optimistic side, it'll take about 5 days to be able to get your data in if you have your MR submitted on the.
Thanks, Joe. And that step 4, wait for the versions database to be imported into the data warehouse. Is that historically or lately, has that been problematic in getting that in a reasonable time or the time we expect, or is that been relatively reliable? I know we've had challenges with getting other data in the data warehouse, but maybe I'm conflating that other data like experiment results and engineering metrics getting into the data warehouse with the usage ping data getting into the data warehouse.
Yeah, so we used to have issues with this where we didn't have an automatic import process. So we were on manual imports every 14 days. Some of the work that Alper and the data team have done over the past a few milestones ago was they actually automated this whole process. So we now have a automated import job that brings that data into the data warehouse. The delays which you're thinking about, that is actually a separate database in a slightly different, that uses slightly different tooling. So Alper, I'm not sure if there's anything that you might want to add to that.
Yeah, we now currently export from versions app every day. So that's, I think, works fine already 3 months or so, or 2 months. So we don't have the problems we had early on due to the manual process. And for the other databases, there are other types of problems, but we don't have it here for versions app due to the type of solution we applied there.
So just to add on to that, Wayne, I think the main thing which your question is about is probably around GitLab.com's replication lag of the production database, and that causing delays in the GitLab.com data being imported in. That's quite a different import process than the one which we use on the versions application. The versions application, what we're doing is we're actually dumping the data into an S3 bucket and then doing an import there. And we're selectively querying what data to dump. So it's a process that is quicker, I'd say, but it's only working on a smaller database size. I don't think it would be appropriate to apply it to a GitLab.com's scale.
Makes sense. I knew some of this, but not all of it, and helped put it all together. Thank you for all the info. What other questions do people have?
I think one other thing about your question about usage ping and the difference between self-hosted and .com. The other thing which I'll mention is the multi-tenant and single tenant natures of self-hosted and .com. So .com being multi-tenant, even though it is a single instance, we have many users, which each take up a single namespace, and that's seen as an account. Whereas on self-hosted, usually one customer has the entire instance, and that's seen as an account. How we structure the queries needs to be slightly different, where currently usage ping is mostly on an instance level. And what we're hoping to do in the future is start segmenting that down towards an account or a namespace level. And this is some of the work that Matthew and the team, the data team, have been working on now that we have usage ping starting to run in the data warehouse.
Great. So another question, I know we have a lot of folks from the product intelligence team on today, which is awesome, and also a number of folks not from the product intelligence team, such as Tatiana and Matthew and others. Did this cover, the product intelligence team is pretty familiar with these components. We've gotten a lot of questions over time, and Jeremy as well. Did this cover what you were hoping we'd cover? And if not, what else would you like us to cover in a future session?
From my point of view, it covers. I'm also familiar with usage ping because I've added some metrics in the past. So mostly I was interested in how it's stored and what happened next. So yeah, it's answer my question.
Thanks, Tatiana. Matthew and Jeremy, anything to add on things you would have also liked seen covered?
No, I think this covered the usage ping details from my perspective. I was already sort of aware of it, but this is some work that the team has been working on that I found interesting, and I wanted to make sure I understood it and supported just by showing up today. And I think it's a cool direction and a good direction to take it. So yeah, I wanted to see how it turned out.
Anything to add, Matthew?
No, not so much. I was here because I was curious. I like the presentation, and I like the direction as well, taken by the team. So, and I like working with them. That's why I showed up.
Thanks, Matthew.
Right. So if there aren't any other questions, then I guess we will end the recording of the presentation here. Once again, I want to give Mikolai and Alina a very big thank you for their work on this framework and the rest of the team over the past few quarters, actually. And thank you for wrapping this up in a great presentation.